Inverter. Think of the inverter as the power translator for older laptop screens. While it is becoming a legacy component in the world of modern LED displays, you are almost certain to encounter it on your CompTIA A+ exam and when repairing older hardware. As you advance in your studies at BCC, understanding the inverter is critical because it represents a specific era of electrical engineering where we had to bridge the gap between low-voltage DC power and high-voltage AC requirements. The purpose, feeding the CCFL. To understand the inverter, you first have to understand what it's feeding, the CCFL, or cold cathode fluorescent lamp. Before we had tiny LEDs, laptops used thin fluorescent tubes, just like the ones in the ceiling of an office. To provide the backlight for the LCD, these tubes have a very specific requirement. They cannot run on the low-voltage direct current DC that comes from a laptop battery or a wall charger. They require high-voltage alternating current AC to ignite the gas inside the tube and make it glow. The inverter's entire job is to take the small amount of DC power from the motherboard and invert, or transform it into the high-voltage AC power the backlight needs to stay lit. The location, hidden in the bezel. If you were to take apart an older laptop, you wouldn't find the inverter on the motherboard. Instead, it is almost always a small, thin circuit board tucked inside the display assembly, usually sitting right at the bottom of the screen behind the plastic bezel. It sits in this location for a safety reason. Because the inverter generates high voltage, the manufacturer wants that high voltage wire to be as short as possible. By placing the inverter inside the lid, the high voltage cable only has to travel an inch or two to reach the backlight tube. The evolution, why it's disappearing. In modern laptops, the inverter has been replaced by LED backlighting. Unlike fluorescent tubes, LEDs run perfectly fine on low-voltage DC power. This means a modern laptop doesn't need an inverter at all. The motherboard sends DC power directly to the screen's LED strip. This is why modern laptop lids are so much thinner and more energy efficient. They've removed the bulky, power-hungry inverter board entirely. Troubleshooting the ghost image. As a technician, the inverter is the first thing you check when a user complains about a black screen. When an inverter fails, the liquid crystals in the LCD are still working, and the computer is still sending a picture. But there is no light behind it. If you suspect an inverter failure, you can perform the flashlight test. Turn the laptop on in a dark room. Hold a bright flashlight directly against the screen. Look very closely at the glass. If you can see a very faint, ghost image of the Windows desktop or the Ubuntu terminal, you know the screen itself is fine, but the inverter or the backlight tube has died. Because inverters are cheap and relatively easy to swap, this is often a very satisfying and cost-effective repair. Comparison for the A+ exam. When you see a question about laptop power and displays, keep these distinctions in mind. Inverter versus motherboard. The motherboard provides low-voltage DC. The inverter converts it to high-voltage AC. CCFL versus LED. If the screen has an inverter, it uses CCFL fluorescent. If it doesn't have an inverter, it uses LED. Safety warning. Because the inverter handles high voltage, never touch the board while the laptop is powered on, even if it's running on battery, as it can deliver a significant electrical shock.